Section C, also known as Module 3, and Module 3 constitutes of limits and continuity, differentiation, and integration. Without further ado, let's get into it. So, start with question 5. Question 5 says, a function f of x is defined as f of x is equal to f of x is equal to x plus 2 and x squared. It's equal to x plus 2 when x is less than 2, and it's equal to x squared when x is greater than 2. And it says, find the limit as x approaches 2. Now the limit as x approaches 2 of f of x, a sports association is planning to construct a running track in the shape of a rectangle surmounted by a semicircle, as shown in the diagram below. The letter x represents the length of the rectangle and r represents the radius of the semicircle. And the perimeter of the track is 600. Show that r is 600 minus 2x over 2 plus pi. So let's do this question now. So you have a rectangle. I'm just going to draw a rectangle for us. You have a rectangle and you have a semicircle. How can I draw a semicircle? You just right, that's a semicircle, and the radius of the semicircle is r. The length is x. Now if the length is x, then that means that down here is also x. If the radius is r, that means the diameter is 2r, and so this side is also 2r. So what does that tell us? The perimeter is going to be equal to x plus 2r plus x plus the perimeter around half a circle, which is pi times r. So the perimeter is actually going to work out to be 2x plus 2r plus pi times r. Nice. But right here, so if the perimeter is this, then perimeter, which is 600, so it's really 600 is equal to 2x. We can factor out r to 2 plus pi, and then now we're good. Now you can subtract 2x from both sides and divide by 2 plus pi to get that r will be equal to 600 minus 2x divided by 2 plus pi. That is r. Nice and easy. Soft. So proven. Now let's look at the next part of the question. The next part of the question goes by asking, it says, hence. I want to pause when it says hence. Hence, meaning we have to use this knowledge somewhere, some way, somehow. It says, hence, determine the length of x that maximizes the area enclosed by the track. So once it's talking about area, I know that the area of that track, the area of this track is going to be equal to the area of the rectangle, which is length times width. So the length is going to be x times 2r, which is 2rx. That's the area of the rectangle, plus area of the semicircle, and area of the semicircle is a half pi r squared. Nice. So that's the area. And next thing I'm going to do is substitute for r, 600 minus 2x over 2 plus pi. That's dangerous. So substituting for r, I'm going to get 2 times 600. I'm just going to do it in one step. Oh boy, Lord help me. 2 times x times 600 is 2 times 600 is 1200 x minus 2x times 2x. Wait, 2x times minus 2x, 2 times, that becomes 4x squared over 2 plus pi. So I worked out this side first, plus a half pi r squared. Oh gosh, I'm gonna have to square this. Oh gosh, what I'm gonna do is I'm gonna write it as plus a half pi r squared is gonna work out to be r squared. Let me try to square the numerator first. Square the numerator first would be 600 squared. 600 squared. Oh God, that's a big number. So I'm just gonna write it as 600 minus 2x all square over 2 plus pi all square. Nice. So let me just write it together as one final statement now that A is working out to be. Just writing it one final time. I'm going to pretty it up. Prettying it up, I can write it as A is equal to 1 over 2 plus pi multiplied by, that's now 1200x minus 4x squared. 1200x minus 4x squared just prettying it up, and this part now I'm going to pretty it up as a half pi times 2 plus pi squared. I'm just going to write this as plus a half pi, that's really pi over 2, and then this 2 is multiplied by, I'm going to change the denominator to 2 times 2 plus pi all squared. So it's 2 times 2 plus pi all squared. And all of this here is being multiplied by 600 minus 2x all squared. Nice and easy. Okay. Now it wants us to find the value of x that maximizes the area. So we need to find dA by dx and set it equal to 0. So dA by dx is going to be equal to, when I differentiate this, I'm going to get 1 over 2 pi, 2 plus pi times, when I differentiate this now, I am getting Differentiate 1200x, I get 1200 minus 8x plus 4 boy. Differentiating this now, I'm going to carry down the power. Now carry down the 2, and then this 2 cancels this 2, carry down the power. So I get pi over 2 plus pi all square. Okay. Carry down the power. Subtract 1 from the power to get 600 minus 2x times the differential inside the bracket, which is negative 2. Instead of doing that negative 2, on the outside, I'm going to rewrite this as minus 2 pi. And then for the area to be maximized, we set this equals 0. So now we need to solve this equation for x. Solve this equation for x. To solve this equation for x, we can multiply through by 2 plus pi all squared. Multiplying through by 2 plus pi all squared, and you get 2 plus pi times 1200 minus 8x minus 2 pi times 600 minus 2x. And now this look normal now. Now we can solve for x. Thank you, God. Now it is normal. So go ahead and solve for x now. Expanding them across. I'm going to get 2 times 1200 is 2400 minus 2 times 8x is minus 16x plus 1200 pi and this 2 times this is this 2400 minus 16x plus 1200 pi minus 8x pi minus 1200 pi minus 4. Minus and minus become plus, so it becomes plus 4x pi equals 0. Now look what I'm going to do. I am going to underline this right here, this 1200 pi and this minus 1200 pi cancel each other. Okay. And all we need to do is group our x terms. If we group our x terms, or even if we factor out the x, if you factor out the x, alright, factoring out the x, you're gonna have, and you don't even need to do that yet, because this 4x pi and this minus 8x pi is minus 4x pi. So what we're really getting is 2400 minus 16x minus 4x pi is equal to 0. All right. Now we can solve for x. We can divide through by 4 to get 600 minus 4x minus, we divide it through by 4, and so this is x pi is equal to 0. So then what does that tell us? That is telling us that we can factor out x right here, and we're going to get minus 4 minus pi minus 4 minus pi, and that is equal to negative 600, because I bring over 600 over here. And so finally, we can divide both sides now to get x is equal to negative 600 over, we divide it by negative 4 minus pi. And so the negatives are going to cancel each other, and so the reality is x is equal to 600 over 4 plus pi. That's the value for x that maximizes the area. X is 600 over 4 plus pi. How do I know that? I know that because d2a by dx squared is automatically negative. d2a by dx squared for this x value is going to be less than 0. I automatically know that. How do I know that? From right here. Minus 8x. You're going to get a negative number. And so this is the value for x that maximizes the area. That is the value of x that maximizes the area. Nice, 600 over 4 plus pi. Now the last part now, it says, let y be equal to minus x sine x minus 2 cos x plus ax plus b. And it says show that the second derivative is x sine x. So I'm going to do it fresh around here. So y is equal to minus x sine x minus 2 cosine x plus ax plus b. Now, if you see y and they ask you for y prime is the first derivative. So we're going to differentiate x sine x by keeping the first. Using product rule, we keep the first. Then we differentiate sine x to get cos x. Plus, we keep the second sine x. Then we differentiate the first to get negative 1. Then we differentiate cos, we get minus sine. So we get plus 2 sine x. Plus, we differentiate ax and we get a. Plus, when we differentiate b, we get 0. So that is y prime. Okay, so in reality, y prime works out to be minus x cos x minus sine x plus 2 sine x. That minus sine x plus 2 sine x is really just plus sine x plus a. Now we need the second derivative. The second derivative is we use product rule again to keep the first times the derivative of the second. When we differentiate cos, we get minus sine x plus keep the second, which is cos x, times the derivative of the first, which is minus 1. Plus, when you differentiate sine, you get cos x. Then when you differentiate a, you get 0. So the second derivative, y double prime, is equal to x sine x, then cos x minus cos x plus cos x So hence minus cos x plus cos x is 0. And so y double prime is equal to x sine x. So prove it. So that's proven. Soft. Nice. Now that we prove it, we're nice. The second part now. The second part is a hence. Anytime it's a hence, you're going to utilize that. It says hence. Hence, determine the specific solution. All right. Now, hence, y double prime is x sine x. So hence just mean that this is y. All right. So hence, we know that y is equal to minus x sine x minus 2 cos x plus ax plus b. So all we're going to do is plug in when x equals 0 and y is equal to 1. What we're getting is 1 is equal to x is 0, so that part works out to be 0, minus 2 times the cosine of 0 plus ax. But what is ax? A times 0 plus a times 0 plus b cos of 0 is, I believe that's 1. Cosine 0. Yes, the cosine of 0 is 1. So we're getting y is equal to minus 2 plus b. And so we transpose for b by adding 2 to both sides, and so b equals 3. And that's when x equals 0. Next we need is when x equals pi. When x is equal to pi, it tells us that y is equal to 6. And so when x is equal to pi, y is 6. So 6 is equal to, the sine of pi is 0. The sine of pi is 0. So we can just put 0 minus 2 times the cos of pi plus a times x is pi plus b, but we found that b is 3. So we're going to subtract 3 from both sides to get 3 is equal to, what's the cos of pi? The cosine of pi is minus 1. That works out to be 2 plus a times pi, and we need a. And so divide through by, subtract 2 first, so 1 is equal to a times pi, and then divide both sides by pi, and so a is equal to 1 over pi. A is 1 over pi. But of course, the question didn't care about all of this long work, you know, they just want the specific solution. So the specific solution is y is equal to minus x sine x minus x sine x minus 2 cos x plus ax, where a is 1 over pi, so it's plus 1 over pi times x plus 3. That takes care of 2013. So this paper easy? Nice. So make sure to just subscribe, all right? And really hope this video was really helpful. and good luck prepping for your exam.